Next one we want to look at here is this one, extraNumber. So in this case, we're given three integers, a, b, and c, so whole numbers, non-negative. Or I guess they could be negative, sorry. I was thinking natural numbers for a second there. But yeah, basically these, they could be 0, they could be negative, they could be, well, I guess technically they couldn't if we look at our constraints here. But they're whole numbers, that's the main thing. And it's guaranteed that two of these are going to be the same as each other. We want to know, what's the value of the third one? What's the third one going to be? So in this case, we're given 2, 7, and 2. And what we want to return is 7, the unique one, the one that's not already in here. Okay, so there are a few ways we could do this. I mean, again, like the last one, we could do something where we sort of have like a bunch of ifs in here. You know, we could say like, okay, well, if A is the same as B, then we'll return C. If A is the same as C, then we'll return B. And if B is the same as C, we're going to return A. Okay, so let's try that. Great. We're done. That's it. Well, is that it? Let's try submitting it. And yeah, that's it. Okay, so that one was, it might have been a record actually. That was pretty fast. Didn't take too long, but we want to look at other ways that we could do the same thing. So what else could we do here? Well, let's make some room. We'll make another copy of this thing. We'll put a 1 at the end of that one. And basically we want to use something a little bit different over here. So we'll say if A minus B. Okay, so basically if A minus B. Well, the only time this is going to return true is if it's something that's going to get typecast to true. So basically any number that's not 0. So if these are the same, if A and B are the same, then, well, basically in that case, we would probably want to return C, right? So if this is false, then we'll return C. Okay, so else return C. Great. And then if we do get this situation, so if we are getting a true for this, that must mean that A and B are different values. So we know that A and B are different. So let's say, well, what about A and C? Are these different? So if these are different, that means A and B are different, and A and C are also different. That must mean that A is the one that we're looking for, right? Because it's different from B and it's also different from C. So it must be unique. Okay, and if not, so we're saying, well, A and B are different, but A and C are the same. So that would actually be this situation. A and B are different, A and C are the same, we should return B. And it's a good thing because that's the only case we haven't covered yet. So we'll try that one. And the first thing we'll notice is looking at this, it actually kind of looks maybe a little more complicated than the first one. This one's nice and organized, all stacked evenly and neatly. This one is all over the place. It's got all these nested ifs and stuff like that. So that's kind of not ideal. You know, it's not the best. So maybe we can clean this up a bit. Actually, I'm going to keep that intact for now. Notice both of these scenarios end with a return. Basically, we're asking ourselves, A minus C? And if yes, we'll return A. If no, we'll return B. So let's try that. We'll close that up. We'll try running that. And yeah, ternary worked for us here. But check it out. In this case, we're still just returning one thing or returning another thing. So we can use another ternary. We'll say A minus B. And if so, we'll return this thing. Otherwise, we'll return C. And let's make our spacing consistent. Let's try deleting this. And does that work? Yeah, that works. That's kind of nice. I gotta say, I think I like that one a little better. We could even, you know, make it a little more efficient than that. Make it something like this. Use a bit of an arrow function here. So we basically just, you know, input, output. And yeah, that still works. So I don't know if we're gonna really be able to get much better than that. I mean, look, that's really efficient, right? That's about as efficient as I think we're gonna get. But who knows? Maybe we can try something else. Let's try to get fancy here. So I want to try something a little bit different here. Let's no longer call that extra number 1, so yeah, extra number. Okay, let's clean this up. I want to get creative. So first of all, let's just make sure nothing else executed. Great, we're getting null. I just wanted to make sure we weren't actually returning something for either of these, so that's good. And it's because it doesn't have the name extra number. It's got the 1 and the 2. That's enough to throw it off. Okay, cool. So what are we going to do here? Well, first of all, we're going to make a new array. It's going to be called nums, and it's going to contain A, B, and C. Okay, so we've got A, B, and C in our array. It's called nums. And actually, you know what I want to do with this? I want to sort these. Okay? So basically, there are two possibilities here. There are two possible situations. So we've got our three numbers. Let's say it's 2, 7, and 2. So when we sort them, we'd get 2, 2, and 7. Basically, this is the case where the outlier, the unique number, is bigger than the other two. So we would end up on the end, on the right. You know, after we sort these, it would be the third one here. The other situation is where our other number is less than, so maybe it was 2, 1, and 2. In which case we'd get 1, 2, 2. So our extreme value, our unique value would end up on the left. What's for sure is that the one in the middle is not unique. It will never be unique. The unique one will only ever end up on the far left or on the far right. It'll never be the one in the middle if we're sorting this. It's not possible, because to be the one in the middle means the one on your left is less than you, the one on your right is greater than you, or less than or equal to, greater than or equal to. Well, we know that it's the unique one, so it couldn't be equal to either of these, and it can't be greater than this one and also less than this one, because that would mean that these are not the same. So it has to be on the left or the right if it's going to be the unique one. Okay, so we know in this case that the one in the middle is one of the repeated values. So since it's one of the repeated values, we're going to say nums at 1, the one in the middle, let's make it negative. Why make it negative? Well, that means if we were to add all of these things up, the one that repeats now has one positive and one negative. So when we add all of these up using our reduce function here, let me know if you have any questions on that, we find that the negative and the positive, they will add up to 0. A lot of students often say, a lot of math students will say they cancel out, but watch out for that. That's not great terminology. They add up to 0. That's really happening here. Okay, so cool. That's kind of a neat way of doing it. Sort of sorting the numbers, setting the middle one to a negative, and then adding them all up, because we know the middle one will not be the unique one. So that's kind of a cool way of doing it. I like that. I think it's neat. But there's one other way we can do this. It's a way that's going to involve bitwise operators. Okay, so we've talked about these before. This is the docs here, bitwise operators. We've got a whole bunch of these. We've talked about these in pretty decent detail. We talked about them in task 33 of the intro section. So you can go back to that video if you didn't catch it. It goes over all of these in a fair amount of detail. I guess we could do like a quick little review for this. Yeah. So we'll go over here to the whiteboard app. Let's see. Pen size is 2 maybe. Come on. All right, great. And what color do we want to use? Let's get some nice colors in here. So yeah, that's probably good. And we'll go with, anyone have a suggestion for a number? Good number to use? Maybe we'll go with like 17 or something like that. Is that too big? I don't know. We're going to start by converting this to binary. So right now it's in decimal, so base 10 in other words. So we would say like in the ones column we have a 7, in the tens column we have a 1, in the hundreds column we have a 0. And then we want to convert this to binary. So in binary, we're not concerned with like tens and ones and all that kind of stuff. We're more concerned with like powers of 2. So I guess we'll use the blue for now. So we're gonna have like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and I think that's probably going to be enough, because if we think about what these values actually are, and let me grab my hand tool because I didn't leave enough room here. Ooh, we need a color that's going to sort of complement both of these. Yeah, okay, perfect. All right, So back to pen. What are these values? 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 3 is, 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. Okay, so basically going back to our number here, 17. So we're going to try to create this in binary. So can we fit a 16 into here? Well, yeah, we can. Maybe this wasn't the best number to use, but basically we can fit a 16. 17 minus 16, we only have 1 left, so we're going to have no 8s, no 4s, no 2s, and 1, 1. So, yeah, now that I'm thinking about it, this is not the best number. Let's change the number. Let's make it 19. Yeah, that's going to be a better number, which means this stuff is going to change. So we'll have the 16, we subtract that. We have 3 left, so we're not going to have any 8s or 4s, but we will have a 2, we will have a 1. Okay, I guess that's at least a little bit better. Let's see, what would be another good one? Let's go with 10. Yeah, we'll choose 10 for the next one. So 10 is not going to have any 16s. It is going to have an 8, no 4s. It is going to have a 2, and it's not going to have a 1. And thanks, that's nice of you to say, but no thanks. Okay, so these are our 2 numbers. Now in terms of the operations that we can do with these, maybe I'll zoom out a bit just so we can keep all this on the screen. So we want to do some binary operations here, some bitwise operators. The way we're going to do it is we'll start with, well, what bitwise operators do we have? Whoops. Okay, bitwise operators. So we have AND, we've got OR, XOR, NOT. Let's start with AND. So basically the way AND works is this. It's going to return a 1 if both of the bits are 1s. It's going to return a 0 in every other case. So it's basically like our logical AND, you know, like if we've got false and false, that's false. False and true, that's false. True and false, that's false. True and true, well, that's true. So going back to here, let's try doing an AND of these things. So we'll do a 19 and, okay, not a bad ampersand. I was expecting worse. Let's find out what that's going to give us. So basically we convert it to binary. So we know what 19 is, it's this. We know what 10 is, it's this. And we want to return basically just if these are both 1s. So 1 and 0, well, no, they're not both 1. 1 and 1, yeah, they're both 1. 0 and 0, definitely not both 1. 0 and 1, not both 1. 1 and yeah, nothing, so that would be a 0. Not both 1. Okay, so what we're getting here is just 2. Okay, so this 19 and 10 should give us 2. So let's find out. Let's just go over here for a sec, and we'll make another one of these. So we'll take our extraNumber function. We'll make this one, we'll give it a 3, I guess. And we'll just say something like return 19 and 10. We're expecting to get 2. So what is it going to give us? Yeah, 2. Okay, cool. So that's how our AND is working. We want to try some other operations here, some other bitwise operators. So maybe if we try 19 or 10. Okay, so that's the pipe character. Normally, like we'd use a double pipe for a logical OR. We'd use a doubled ampersand for a logical AND. So basically, if either of these is a 1, the result here is going to be a 1. So 1 or 0, yeah, 1. 1 or 1, still 1. 0 or 0, no, that's going to be a 0. But this is going to be 1, this is going to be 1 because there's a 1 here, there's a 1 here. Okay, so what are we getting from that one? Well, 1 plus 2, that's 3, plus 8, that's 11, plus 16, is that 27? I think that might be 27, unless I did my math wrong. So let's check it, and maybe we'll have to correct my math over there. Let's find out. But no, 27, that's exactly what we should expect. Okay, so that's bitwise OR, but I want to get into this one, bitwise XOR. We're not as used to the idea of XOR. Like we've done lots of ANDs and ORs just in logic, But XOR, that's a bit different. So we're using the caret symbol. It's what we would usually use for like exponentiation when we're just writing it out, but not in terms of the actual code here. So watch out for that. In fact, I've seen people get kind of confused because, they're like, they want to do like 2 to the power 5, and they do 2 and then this and then a 5, and they get some weird value which represents the XOR result from this. So watch out for that. Okay, so the way XOR works, it's exclusive OR. So basically, the first is a 1, or the second is a 1, but not both. Okay, so in this case, one of them is a 1. Cool, so we'll put a 1 there. Both of them are 1, so that'll be a 0. In this case, both of them are 0s, so that'll be a 0 as well. We've got exactly 1, 1 here, so that's good. We've got exactly 1, 1 here, so that's good as well. We get 1, 1, 0, 0, 1. So what's that equal to? Well, it's 16 plus 8, so that's 24, plus 1, 25. Okay, so we should get 25 for this. Let's try that. Yeah, 25. And keep in mind, that is not exponentiation. A lot of people look at this and think it means exponentiation. Keep in mind, 19 to the power 10 would actually be this number, which looks almost like an Ottawa phone number. But anyway, the point is, let's run that. Yeah, we get our 25 here. So that's what XOR is all about. It's kind of weird if you think about it. I want to focus more on what we get when we look at the binary part of this. So like we started with this 19. That's one way of looking at it anyway. We started with 19, and with 19 we have 1, 0, 0, 1, 1. Okay? And basically what this part is telling us is anywhere where we see a 1 here in this number, any of those columns, we want to actually change what we have in the original number. So which columns are we talking about? Ooh, we need another color. Oh, perfect. Okay, so basically right here, we're going to change the value. Right here, we're going to change the value. And everything else, we're going to leave it the same. So basically, instead of 1, 0, 0, 1, 1, we're going to get 1, 1, 0, 0, 1, which is what we got. Okay, cool. So we basically only changed those bits, which means if we were to do this again, like, take the result, take our 25 here. Come on. There we go. Okay, so if we were to take our 25 and do an XOR with 10 again, what would happen? So basically, here's our 25, here's our 10, which means we're going to be, again, switching this and this, right? Because those are the columns where we had 1s in our 10 here. So we're going to switch those. So we get 1, 0, 0, 1, 1. That looks kind of familiar. It's 19. It's what we started with. And it kind of makes sense. So it's kind of like, we're starting with the 19, and then we're doing an XOR with 10, and that switches just these bits. But then we want to switch them back, so we do another XOR with 10, and it switches them back, and we're back to 19. Well, hey, that's kind of interesting, because that means if we were to do something like 19 XOR 10 XOR 10, we would just get the 19 again. And it doesn't really matter where in this process we put the 19. It's still just going to end up being 19 here. I mean, it's going to have the same bits reversed both times. And it also doesn't really matter what the other number is, or what the other numbers are. As long as one of them is unique, it's going to have a particular set of bits switched, and then that same particular set of bits switched back. So we're going to get the unique value here. What I'm trying to say is this. It works. So as it turns out, yeah, it can be more efficient. That's pretty cool. So really the best way of doing this, maybe be like this, Yeah, I think maybe that's best. Let's find out. Pretty strong, I'd say. Pretty strong. I think we're saving characters over this. Now, which one is the most clear? I don't know. That's a tougher question. I mean, it's not exactly obvious just looking at this one that it would actually solve this problem. We sort of needed a bit of an explanation on why that works. And I still don't even know if it's clear. But anyway, the point is, something like this, we'd probably want to include some comments here. So like, sort the numbers. Middle one is guaranteed to be a repeat. And then for this part, set the middle number negative. And then for the last part, add them all up. Maybe this is more clear now. I don't know. For something like this, it's basically doing the same thing as this one, but, well, a little more efficient, actually, a little less repetition. But again, I don't know if it's super clear. There are ways we can make it more clear, like saying if A equals B, or if A equals C, or technically more accurately, not equals B, not equals C in this case. But, yeah, I don't know. It's up to you. So we've got lots of ways of doing this. Let's just see if that passes all the hiddens as well. Yeah, it does. So, cool. I guess we'll wrap this one up there for now. Let me know if you have any questions, comments, or concerns. And yeah, that's it. Okay, so next time we meet, which,